There was a time in Earth's long history when the very air itself was different. Imagine breathing an atmosphere so rich in oxygen that each inhale left you dizzy, as though the forest around you were pouring too much life into your lungs. Fires leapt from sparks into infernos, and insects, no longer confined by the limits of size, spread their wings as wide as your arm. Dragonflies became hunters of the skies. Scorpions prowled the ground at lengths close to a meter, and millipedes stretched across the forest floor like moving roads. It was the Carboniferous period, nearly 300 million years ago, when the planet exhaled abundance into the air for 60 million years. What would it have felt like to walk beneath those towering, hollow trees? To crouch beside swamps that would one day turn into coal? To glance upward and see shadows of wings blotting out the sun? Could a human even survive a breath in that world? Or would the very air that sustained giants undo us? You're listening to Ancient Fireside, where we wander into the hidden chapters of Earth's story. If you'd like to keep exploring these strange and haunting worlds, you're welcome to like, subscribe, and leave a comment with the place and the time you're joining us tonight. And now, let us step softly into that forest before dawn, where the first whispers of a world unlike our own begin to rise. Close your eyes for a moment and imagine the world as it was more than 300 million years ago. Not the familiar landscapes of cities, roads, or farmlands, not even the rolling hills of early agriculture. Instead, the earth lay wrapped in a cloak of heat and moisture, as if the entire planet were a greenhouse. The land masses were gathering into a single immense puzzle piece, drifting together into what we now call Pangaea. But to the creatures alive then, there was no word, no label, only endless forests, marshes, and skies that pressed low with heavy clouds. It was the Carboniferous period, stretching from about 359 million to 299 million years before us, a chapter of deep time that shaped the world beneath our feet in ways we still feel today. Those forests did not resemble the ones you might hike through now. Imagine trees rising like columns in a forgotten cathedral, many of them 30 meters tall, yet strangely hollow inside. The lepidodendron, one of the great giants of that era, carried a trunk patterned like a mosaic of diamond-shaped scars. Its bark bore the imprint of scales, as if the tree itself were a reptile turned to wood. Instead of dropping seeds, it released clouds of spores, tiny dust motes drifting into the sticky air, filling the shadows like golden smoke. Surrounding them grew horsetails as thick as a person's arm, and ferns that arched in vast green umbrellas. This lush, waterlogged environment was the planet's great coal workshop. When plants died, they fell into swamps where decay was slowed by the oxygen-poor mud. Over millions of years, those mats of fallen trunks and fronds were pressed and hidden away, transformed into the seams of coal we still mine and burn today. Every time a piece of coal is struck by a match, it is not just fuel, it is sunlight from the Carboniferous. Sunlight captured by those ancient forests and locked away like a diary of photosynthesis. That fact alone makes the air feel heavy, doesn't it? You breathe in, and for a moment, you're pulling in whispers from a time before humanity had even the faintest spark. But there is something quirky here, something almost whimsical. The trunks of those lepidodendron trees were not just hollow, they were fragile. When storms toppled them, they collapsed like enormous drinking straws, leaving gaps that animals might crawl through. Some paleontologists suggest that the patterns of bark imprints left behind were so distinctive that ancient cultures who stumbled upon them millions of years later may have mistaken them for carved relics. Imagine a fossilized trunk wall covered in diamond patterns, and think of how easily it could be confused with the handiwork of a forgotten people. Nature had been carving long before humans thought to chisel stone, and yet not every detail is perfectly pinned down. Debate continues among geologists about just how unified Pangaea truly was during this early stage. The continents were on the move, yes, but were they locked fully into one landmass? Or were there still shallow seas separating chunks that had not quite fused? Different models, based on magnetic minerals frozen in rock, draw the outlines differently. Some suggest a single supercontinent rising like a giant's fist, while others hint at an archipelago slowly knitting itself together. It is a reminder that even something as seemingly straightforward as the shape of the Earth is filtered through layers of uncertainty. Now let us slow down and walk with sound. In your imagination, let your bare feet press into wet ground. Each step leaves a print that fills quickly with water, rippling like a mirror. Overhead, the canopy is so thick that daylight struggles to reach you. The air is sweet and damp, heavy with the perfume of spores, like the scent of mushrooms multiplied tenfold. You hear the occasional groan of trunks shifting, the creak of wood that is alive and yet so brittle it might crumble. And every so often you catch the flicker of movement, though not from birds. For no bird had yet taken wing, not from mammals, for they were far in the future, but from creatures stranger, quieter, waiting in shadows. There is an emotional weight to this forest. It feels at once fertile and suffocating. On one hand, life is exploding, reaching up and out, creating the very foundation of energy that later worlds will inherit. On the other, there is a sense of stillness, of time stretched so long that our human sense of story almost breaks. These trees grew, toppled, and were buried without ever knowing the gaze of human eyes. Their purpose, if we can call it that, was silent accumulation. Layer upon layer of matter, stored for futures they could never predict. And as we look at this moment from today, we might ask ourselves a gentle question. What would it feel like to be human in such an atmosphere? The truth is, if we stood there, breathing in the air of that swamp, we would struggle. The oxygen was building, climbing toward levels far higher than the 21% we rely on now. It would have been intoxicating, even dangerous to our lungs. Our bodies are calibrated for balance, not for extremes, and the Carboniferous was nothing if not extreme. We are visitors here in thought only, guests guided by the coal and the fossils, safe behind the glass wall of time. Still, this beginning matters. Because the Carboniferous forest is not just a backdrop, not just scenery, it is the stage on which the drama of oversized life will soon play. The very air that hummed in those hollow trunks, the very swamps that swallowed fallen trees. They were preparing a canvas. That canvas would soon be painted with creatures whose size seems almost comic, almost unbelievable to us now. But before wings stretched wider than a child's arms, before centipedes crawled longer than a bed, there was only this forest, quiet, wet, vast, and humming with invisible change. And so, as you breathe softly now, picture those trunks rising around you like pillars in a dream cathedral, their patterned bark glowing faintly in the light of a prehistoric dawn. Let the damp air gather on your skin. Let the ground sink gently beneath your step. This is the threshold, the entryway into a world both alien and intimate, a world built of air and wood and silence. From here, the story widens, and the air itself will become the most powerful sculptor of life. In the hush of that damp forest, one truth becomes clear. When the air grows too rich, fire waits patiently, and every breath carries both promise and peril. If you linger in that Carboniferous forest long enough, you begin to notice something unusual about the air. It is not only damp, heavy with spores, but also strangely sharp, as if each breath were richer, brighter, almost too much of a good thing. Scientists studying the chemical traces left in ancient rocks and charcoal deposits tell us that oxygen levels rose then to about 35% of the atmosphere, compared with the 21% we live with today. That may not sound like a dramatic jump, just a few numbers apart, but to the chemistry of life and fire, it was a revolution. Think of oxygen as the invisible conductor of both breath and flame. With more of it, every spark is amplified, every inhale supercharged. For a human, stepping into such an environment would feel dizzying, even dangerous. The body, accustomed to moderation, would react as though intoxicated, giddy at first, then strained. But for the forest, for the world itself, this richness of oxygen drew lines of fire across the land. Lightning storms that today might pass with a few charred trees would then set whole landscapes ablaze. Imagine a single bolt splitting the sky, striking a dry patch of peat, and suddenly the swamp is not just smoking, it is a torch stretching for miles, a river of flame eating its way through trunks and spores. There is something quirky about this image, isn't there? Fire in the Carboniferous was not an occasional visitor, but a near constant presence. Paleobotanists have found layers of fossilized charcoal stacked in the geologic record like pages in a burned diary. These layers suggest that wildfires were not rare disasters, but part of the regular rhythm of the ecosystem. In fact, some researchers propose that entire cycles of vegetation were pruned by firestorms, only to regrow denser than before, feeding the oxygen pump once again. Fire, paradoxically, may have been both a destroyer and a gardener, shaping the forest in ways no animal could. And in those moments when flames tore through the undergrowth, the air itself would have glowed with embers, a scene both terrifying and eerily beautiful. Yet not all scientists agree on the precision of these oxygen estimates. The 35% figure is drawn from multiple proxies: charcoal abundance, the ratio of isotopes and minerals, and computer models of plant productivity. But each of these comes with uncertainties. Was the oxygen really as high everywhere? Or were there regional differences, with some valleys lower and some swamps more enriched? Did the atmosphere truly hold steady at those elevated levels for millions of years, or did it fluctuate wildly, spiking and dipping like the breath of a restless sleeper? Debate continues, and the numbers may shift as new evidence arrives. But the central truth holds firm. Oxygen was higher, fires were fiercer, and the world breathed differently than it does today. Let yourself imagine a simple scene. You are camping in a modern forest, perhaps under pine or oak. You strike a match, light a small fire, and the flames climb politely, controlled by the measured air around you. Now picture the same act in the Carboniferous. That single match, if such a thing could exist then, might be enough to transform a clearing into a furnace. The resinous trunks of giant lycopsids would flare like torches, and the hollow cores would turn into chimneys. Instead of warming your hands, You would be racing from a conflagration too swift to outrun. The thought sends a little shiver, doesn't it? A reminder that survival is as much about atmosphere as about strength. And still, for all its danger, that oxygen-rich world was also a cradle of possibilities. Higher oxygen supported the gigantism of insects and arthropods, creatures that would soon dominate the shadows and skies. It was as if the very air conspired to push life into new shapes, larger and stranger than before. Fire and growth, destruction and expansion, braided together into a single rhythm. Each blaze cleared ground for fresh spores. Each regrowth pumped out even more oxygen, and the cycle spun onward. The forest was not just alive. It was breathing in a way that felt almost feverish, exhaling into an atmosphere that could at any moment ignite. If you listen closely now, in this imagined journey, you can almost hear the crackle, not of your modern fireplace, with its neat logs and controlled sparks, but of entire valleys alight. The sound would not have been gentle. It would have been a roar, a chorus of flames racing along treetops, echoing through hollows, and booming as trunks collapsed in showers of sparks. Yet after the roar, silence would return, and with it, the slow persistence of regrowth. Life did not despair in the face of fire. It adapted, waited, and then reached up again. Emotionally, this knowledge invites both awe and unease. To think of forests where fire was as common as rain is to step into a world that feels both alien and familiar. Alien, because our instinct is to fear flame, to see it as an intruder. Familiar, because even now wildfires sweep across continents, and the cycle of burn and regrow continues, though under different skies. The Carboniferous was simply an amplified version, a louder echo of processes still at work, and there is a soft wit hiding in this too. Imagine trying to roast a marshmallow in such a place. Before you could lift your stick, the whole forest might join your campfire. The air itself was a prankster, daring every spark to overperform. The joke, of course, would be on you, as your campsite vanished in a glow fit for the gods. As debates among geologists remind us, the details may shift, but the image remains compelling. A world where breathing too deeply was a thrill ride, where lightning storms painted maps of fire across the continents, and where life learned to live with constant risk. The Carboniferous did not wait for human witnesses, but it left enough evidence that we can trace its fiery fingerprints today. So as you lie back now, picture the forest floor glowing in scattered embers, the trunks steaming after rain, the sky swollen with smoke that blotted out the stars. Imagine the heat brushing your face, the sudden hush after the flames passed, the smell of ash mingled with spores. This is the atmosphere of that time. Too much, too bright, too quick. And yet, it was precisely this volatility that carved the stage for the creatures soon to come. Beings whose size and strangeness were fueled by the very same air that set their forests aflame. From the ashes of these fires, in swamps that swallowed trunks and footprints alike, the earth was quietly storing a memory that would one day burn in our stoves and lanterns. The coal of an ancient world waiting in silence. After the fires swept through, after the sparks died down and the forest stood scarred, something quiet and patient took over. The Carboniferous world was a master of recycling. What fell into its swamps, giant tree trunks, mats of ferns, even footprints that lingered in mud, did not simply vanish. They sank into layers of waterlogged ground where oxygen could not easily follow. There, decay slowed to a crawl, and time began its long alchemy. Over millions of years, the weight of new forests pressed down upon the old, squeezing out water, leaving behind black seams of carbon. This is how the coal we burn today was born, the petrified breath of ancient forests, stored like memories beneath our feet. The fact is straightforward, and yet it carries immense weight. Each lump of coal dug from the earth is the residue of photosynthesis, sunlight captured 300 million years ago, trapped within the bodies of trees that no human eye ever saw alive. When you imagine a locomotive steaming across a plain in the 19th century, or a light bulb glowing in a city window for the first time, know that both were powered by forests of the Carboniferous. The energy of that world was borrowed, carried forward across epochs, only to be released in a sudden flare of human industry. There is something astonishing about that continuity, as if we are still tied by breath to a world long buried. But buried forests left behind more than fuel. The swamps preserved impressions of bark, leaves, and even delicate traces of creatures that wandered their surfaces. The lepidodendron, with its patterned skin, sometimes collapsed in ways that left perfect casts in the sediment, as though an artist had carved their diamond-shaped patterns into clay. When miners in later centuries stumbled across these fossilized trunks, they often mistook them for strange works of art, or even thought they might be relics of ancient civilizations. It is a quirky detail that the first collectors of such fossils occasionally displayed them as curiosities, marveling at the geometry without realizing they were looking at the handiwork of nature herself. And then there are the footprints, pressed into mud and preserved by chance. Trackways of arthropods and amphibians stretch across slabs of stone, recording journeys that ended before mammals ever drew breath. Some look like delicate chains of dots, others like wide trails from creatures the size of dogs or longer. To walk alongside these frozen paths is to share a moment of intimacy with beings that have no names, no descendants, and no stories, save the one their footprints whisper through stone. Of course, the process that created these coal beds is still debated in its finer details. Geologists and paleobotanists argue about how quickly the dead vegetation accumulated, how deeply it was buried, and whether regional climates accelerated or slowed the transformation. Some suggest that rapid flooding sealed the layers efficiently, locking away vast reserves of organic matter at once. Others believe the process was more gradual, with swamps pulsing in and out of wetness, each cycle adding another film of plant matter to the stack. Even the role of fungi, organisms that eventually evolved the ability to break down lignin, the tough material in woody plants, is a matter of discussion. Before these fungi appeared, decomposition was incomplete, and enormous amounts of plant material slipped away into burial. Once the fungi learned to digest lignin, the world's recycling system changed, and the coal-forming window began to close. Now pause and picture the swamp itself, not as an abstract process, but as a place you could walk, though you would sink quickly. The ground beneath you would be a quilt of fallen fronds, soft and spongy, releasing bubbles as you stepped. The air would shimmer with the hum of insects, and the smell, thick, resinous, almost sweet, would cling to your throat. Look down, and you might see the glimmer of water pooling in your footprints, reflecting the canopy above. Look closer still, and you might imagine those same impressions hardening, preserved by silt, ready to last long after your own time. It is as if every step in that world risked becoming a fossil, every movement a permanent echo. There is an emotional resonance in this realization. Coal, so ordinary in our modern vocabulary, is actually the memory of an entire biosphere. To touch it is to place your hand on a time capsule, to feel the weight of millions of years compressed into a single black sheen. It is both comforting and unsettling. Comforting, because it connects us to the great cycles of Earth. Unsettling, because it reminds us of how fleeting any present moment can be. And perhaps there is a quiet wit here as well. Imagine a Carboniferous tree, towering and hollow, falling into a swamp with a crash. It might have taken centuries to grow, yet within days it would be sinking, disappearing into the muck. If that tree could somehow know that hundreds of millions of years later, it would be fueling the lights of a midnight diner or the glow of a child's bedside lamp, perhaps it would find the whole arrangement absurd. The forest became not only a cathedral of life, but a pantry for future civilizations, stocked without any plan, opened only by accident. The debates about timing and mechanism will continue, but the imagery remains clear. The swamps were a vast recording studio, layering track upon track of organic matter, pressing them into records that we would one day play as heat and light. Every fossilized bark impression, every coal seam, every preserved footprint is part of that chorus. It is as though the earth itself was writing a song, one verse after another, storing it until someone or something came along to listen. As you rest here in this imagination, hear the hush of the swamp around you, smell the wet decay, feel the give of spongy ground beneath your feet. Watch the mist rising from black pools and see the faint glow of fireflies, or what passed for them then, drifting between fronds. This was a world where memory was constantly written into the mud, where silence was not emptiness, but anticipation. And in the stillness of that swamp, you realize something important. The Carboniferous was not just a time of growth or fire, it was also a time of preservation. Life was not only living, it was leaving messages, pressed into stone, to be read long after its own voice had faded. From these quiet swamps of memory, where trunks and footprints were pressed into coal, the air itself began to push bodies toward impossible sizes, as though the atmosphere were daring creatures to test their limits. If this strange breathing forest is keeping you company tonight, you're welcome to join our Fireside Circle at Ancient Fireside. Tap like or subscribe if it feels right, and tell us where and when you're listening in the comments. Imagine yourself crouched low in the undergrowth of that Carboniferous forest, damp earth cool against your skin, the air pressing close and heavy. Something rustles nearby, not the thump of paws or the crack of a reptile's tail, but a lighter sound, like paper crinkling in the dark. You look, and there, in the shadow of a fallen lepidodendron, rests a creature that seems both familiar and utterly foreign. A giant insect, its wings veined like stained glass, lies still, its sides pulsing faintly as it breathes. The secret of its size is not muscle or bone, but air itself, flowing through a delicate lattice hidden within its body, the tracheal tubes. Somewhere behind us, a small fire ticks in the dark, a reminder that even air can change shape and size. Here lies the fact: insects do not breathe with lungs, not as we do. Instead, they possess a branching system of tiny tubes, tracheae, that deliver oxygen directly to their tissues. In our modern world, this system places a strict limit on their size. The farther oxygen must travel by passive diffusion, the harder it is to reach the innermost cells. That is why today's dragonflies, even at their largest, stretch only a few inches across. Their bodies are bound by physics. But in the Carboniferous, with oxygen making up around 35% of the air, diffusion worked more efficiently. Every wing beat, every flick of an antenna could be fueled by a denser, richer breath. The ceiling of size lifted, and insects expanded into shapes that seem like myths. And then comes a quirky character, the Paleodictyoptera, sometimes called the six-winged insects. Picture a creature neither butterfly nor dragonfly, with pairs of wings sprouting not only from its midsection, but also from its thorax, so that it carried 6 instead of 4. These wings may have acted less for flight and more like stabilizers, tiny sails catching air as it glided between trunks. Some reconstructions even suggest these creatures secreted a sugary fluid from their beaks, sipping the resin of trees, like ancient connoisseurs of syrup. To watch one feed would have been like seeing a living ornament, a glider hovering with unnecessary flamboyance, drifting through the forest haze. Their very shape reminds us how experimental evolution was in that oxygen-thick world. But as with all stories from deep time, not everyone agrees on the details. Was oxygen truly the sole driver of gigantism in insects? Some scientists argue that other factors may have played equally important roles. Higher atmospheric pressure, for instance, may have influenced flight mechanics, allowing wings to push against denser air. The absence of aerial vertebrate predators, no birds, no bats, might have given insects free rein of the skies, encouraging size as a survival strategy. There is even debate over whether gigantism peaked exactly when oxygen levels did, or whether the timing was offset, suggesting more complex interactions between climate, predators, and prey. The truth may be a tapestry of causes, woven tighter than a single thread of oxygen can explain. Now close your eyes and try to feel this difference in your own body. Imagine taking a breath of such oxygen-rich air. It would be like inhaling light itself, every cell in your body tingling with surplus energy. Your chest might ache with the pressure of it, your head dizzy with the flood. And then imagine being an insect, small tubes running through your frame, suddenly capable of channeling more life with each second. The body grows, not because it chooses to, but because the air allows it to. The forest becomes populated by creatures whose very existence is a reflection of atmosphere, a mirror of chemical abundance. There is something tender in this thought, almost poetic. Size, so often linked in our human minds to strength or ambition, was here a passive gift of the sky. No insect schemed to be gigantic. No dragonfly aspired to tower over ponds. They were enlarged by the generosity, or perhaps the recklessness, of their world. Their wings stretched wider because diffusion whispered, "You may." Their legs grew longer because the air said, "I will carry you." In this way, the Carboniferous teaches us that environment is not just backdrop, but sculptor, shaping bodies as surely as clay shapes a pot. But the forest was not without its risks. Insects, for all their growth, still carried fragile skeletons on the outside, exoskeletons that cracked under weight if pushed too far. The balance between size and support was delicate, and some evolutionary experiments likely ended in collapse. Fossil fragments hint at bodies too large for their own architecture, creatures that perhaps struggled to molt, their shells too heavy to shed. It is a gentle reminder that abundance brings opportunity, but also danger. Growth without limits can stumble. Picture the scene again, this time with sound. The air is alive with the hiss of wings, louder and deeper than any insect chorus today. A six-winged Paleodictyoptera drifts past your shoulder, its body casting a brief shadow across your face. The forest feels like a dream painted too vividly, its details exaggerated, its inhabitants half-fantastical. And in the midst of it, you sense the fragility behind the spectacle, that these shapes, as strange as they are, belong only to this brief window of Earth's history, a period when the sky itself permitted such extravagance. And if you let your mind wander toward humor, you might picture what it would be like to live among them. Imagine trying to read a book by lantern light in a swampy cave, only to have a dragonfly the size of your arm thump against the flame, nearly toppling your lamp. Or imagine sitting down to rest against a log, only to realize that the log is in fact the molted skin of an insect larger than your dog. The Carboniferous would have been a place where wit and unease blended seamlessly, every corner both fascinating and unsettling. Scientists continue to study the traces of this time, analyzing the structure of tracheal tubes in fossilized insects, comparing them to living species, and running experiments in hyperoxic chambers. Each result brings us closer, but also reminds us of the limits of reconstruction. The Carboniferous forest was not a laboratory. It was a living, breathing chaos, with too many variables for neat equations. Perhaps that is why its creatures still feel dreamlike to us, half real and half imagined, suspended between science and story. So breathe gently now, as though through tracheal tubes yourself, and let the forest press its heavy air around you. Picture wings flickering like stained glass above, sugar seekers sipping resin, and debates echoing quietly in the background. This is the first glimpse of a world where air itself sculpted the boundaries of life, where size was less a choice than a condition of being. And when we step from imagination back into experiment, we discover that even today, in controlled chambers, insects still listen to the whispers of oxygen, stretching larger when the air grows rich. Imagine for a moment that we could bottle the Carboniferous air, pack it into a cylinder, and release it into a sealed room today. What would happen if a living creature, something small and ordinary, were placed inside? The answer, strangely enough, is not pure speculation. In the past few decades, scientists have done something very close to this. They have recreated ancient atmospheres in the laboratory, dialing up the oxygen to levels that mimic that long-gone world. And when they placed insects inside those glowing chambers, something remarkable occurred. The bodies of those insects responded in ways that echoed their prehistoric cousins. They grew larger. Here is the fact, plain and powerful. In 2007, a team of researchers at Arizona State University raised dragonfly larvae under different atmospheric conditions. In chambers where oxygen levels were high, close to 30% or more, the dragonflies developed into adults with wingspans significantly broader than those raised in normal air. Other experiments with cockroaches, beetles, and even crickets showed similar results. More oxygen meant larger sizes, longer bodies, or thicker exoskeletons. It was as if the insects were listening to an old song their bodies still remembered, a tune composed in the Carboniferous, and hummed quietly through time. And yet the laboratory is not the forest, and in these controlled chambers, odd quirks appear. One researcher described the glowing red of the hyperoxic rooms, when oxygen fills the air so richly, even the slightest spark must be avoided. Inside, the insects crawled and buzzed under artificial lights, their outlines casting long shadows on the chamber walls. A cockroach scuttling in such a room looks almost like it is attending a gym session, bulking up in the atmosphere, its body thickening with every molt. It is a quirky, almost comical image. Gym roaches pumping invisible iron in a world of overabundance, training for a competition they will never enter. Yet these trials are not jokes. They are mirrors, small reflections of a planet that once lived under conditions we can only recreate in steel boxes. But here, too, the story is layered with debate. Does oxygen alone account for the gigantism of the Carboniferous? The lab results are compelling, but not all scientists are convinced they tell the whole tale. Some point out that insects in hyperoxic chambers do grow larger, yes, but not always to the sizes seen in fossils. The Meganeura, the dragonfly with wings broader than a man's arm, does not appear after a few generations of chamber breeding. This suggests that while oxygen was a crucial factor, other elements, climate, absence of predators, and evolutionary experimentation, must have combined to unlock the extreme forms of that age. Others argue that modern insects are simply too far removed, their lineages adapted to lower oxygen Earth, and cannot fully replay the past even when the air allows it. The debate continues, reminding us that the past is not a script we can stage with perfect accuracy, but a story we interpret with fragments and echoes. Still, let us pause to feel what these experiments mean. Imagine leaning against the glass of such a chamber, watching a dragonfly spread its wider than normal wings. Its body glints under fluorescent light, the veins of its wings shining like threads of silver. You hear the buzz of crickets that chirp louder, fuller, as if their tiny lungs were overflowing with breath. The room hums not with words, but with the rhythm of abundance. It is a rhythm our bodies do not know, yet one that seems oddly familiar, as though humanity has always carried the memory of richer skies in the marrow of our bones. Emotionally, there is something deeply moving about these recreations. We are not just studying insects, we are communing with time itself. By adjusting the knobs of gas tanks, by sealing glass doors, we create a portal to a world older than our species, older than mammals, older even than the first reptiles. We listen to what happens when oxygen is abundant, and in those responses, we catch a glimpse of a forgotten Earth. The laboratory becomes less a sterile room and more a shrine, glowing red with ancient fire, humming with wings that recall a past alien and wondrous. And with that comes a touch of humor. Picture a graduate student tasked with feeding oversized cockroaches in a hyperoxic chamber, jotting notes as the creatures scuttle around, their antennae brushing the glass. Somewhere in the back of their mind, the student must wonder, am I raising a pet or a monster? The insects, oblivious, carry on, their bodies obeying only the laws of chemistry and biology, unaware that they are participants in a reenactment staged for curious humans. The wit lies in the contrast, our serious science framed against the casual indifference of the cockroach, which simply breathes and grows, no matter the century. Of course, the debates extend further. How stable were those high oxygen levels? Did insects evolve to their enormous sizes gradually, step by step, or were there sudden bursts linked to atmospheric spikes? Some studies suggest that oxygen levels may have fluctuated within the Carboniferous, rising high but also dipping, creating pulses of opportunity rather than a steady backdrop. If so, gigantism may have been less a permanent condition and more a series of evolutionary gambles, some won, some lost. Each fossil we uncover is a single card from a deck whose game we cannot fully see. So take a slow breath now. Picture that red-lit laboratory, the quiet hiss of oxygen tanks feeding the chamber, the faint scratching of insect legs on glass. Feel how strange it is to witness the past replayed in miniature, to see creatures respond instinctively to conditions long vanished. It is both eerie and comforting, as though the earth carries memories in the very blueprints of life, memories that can be awakened under the right sky. And beyond the glass, imagine the larger forest, the true Carboniferous canopy, stretching miles high, buzzing not with chamber-born roaches, but with wild, giant flyers and crawlers. The lab experiment is a whisper, a hint. The real forest was the chorus. The chamber hums softly, but the swamp thundered with life, with wings that shook the air and bodies that stretched beyond belief. This is what experiments teach us. Not certainty, but echoes. They tell us that oxygen had power, that bodies respond when air grows rich, but they also remind us of what cannot be recreated. The totality of an ancient world, the combination of fire, forest, predator, and prey. Still, even an echo can be enough to lull us into wonder, to let us fall asleep imagining dragonflies as long as your arm, buzzing through the haze of a sky swollen with breath. And yet, not all creatures of the Carboniferous clung to air. Some were learning to stretch their limbs toward land, testing eggs and footsteps beyond the swamp, carrying the story of size and survival into the age of reptiles. Picture the Carboniferous forest after a rainfall, the canopy dripping like 100 leaky roofs. Beneath the green columns of lepidodendron and calamites, pools gather in shallow depressions. The water is still, but not empty. Something stirs, something broad and heavy, eyes just peeking above the surface. At first glance, you might think of a crocodile, but this is no reptile. It is an amphibian, a creature from the group we call temnospondyls, and it is enormous by amphibian standards, stretching as long as a man is tall. This is a world where even the dwellers of swamp and pond swelled to giant proportions, their bodies buoyed by water and enriched by the oxygen-rich air. Here is the fact. During the Carboniferous, amphibians were among the dominant vertebrates on land and water. Some species of temnospondyls reached lengths of 2 to 4 meters with wide, flat heads and jaws lined with sharp teeth. They lurked in rivers and marshes, ambush predators waiting for smaller fish, insects, or even other amphibians. Their sheer size set them apart from modern frogs and salamanders, which seem delicate by comparison. In a forest alive with giant insects, these amphibians claimed their place as heavyweight hunters, the crocodiles before crocodiles. But alongside these giants, something even more revolutionary was unfolding. Small, lizard-like creatures, scarcely noticed in their own time, began experimenting with a new way of life. They were the earliest amniotes, the ancestors of reptiles, birds, and mammals. Unlike amphibians, whose eggs had to be laid in water, amniotes carried their nurseries within protective shells or membranes, allowing them to colonize drier ground. With this step came independence from the swamp, a passport to new territories. Their bodies were modest, far from giant, but their innovation would eventually reshape the history of land animals. To think of them here, scurrying among roots and leaf litter, is to glimpse the first sparks of futures yet to come. There is a quirky detail in all this, one that continues to puzzle scientists. Fossilized traces of early reptilian eggs are frustratingly rare, leaving us to guess at their appearance. Some evidence suggests the first amniote eggs may have had soft, leathery shells, not the hard, brittle casings of modern chicken eggs. If so, they would have been far less likely to fossilize, dissolving into the soil long before stone could preserve them. Imagine stumbling upon such eggs in the Carboniferous, translucent sacs tucked beneath damp leaves, glistening like jelly in the morning mist. They would not look like treasures of evolutionary destiny. They would look like something a child might poke with a stick, unaware that inside was the blueprint of birds, mammals, and, eventually, us. And then comes the debate. How quickly did amniotes begin to thrive under these conditions? Some paleontologists argue that their rise was gradual, their early forms staying small and unobtrusive for millions of years, overshadowed by the amphibian giants around them. Others suggest that the oxygen-rich air may have accelerated their success, giving them metabolic advantages that let them explore new niches. The fossil record, patchy as it is, leaves room for interpretation. Were these first reptiles pioneers boldly striking out? Or were they timid stragglers, surviving in the shadows until conditions tipped in their favor? The truth remains uncertain, tucked away in stone fragments waiting to be read. Now slow your breath and imagine standing at the edge of a carboniferous pond. The air is thick and sweet, buzzing with wings. You hear a sudden splash, and a temnospondyle rises, water streaming off its broad skull. Its eyes glisten, unblinking, as it slips forward in a ripple of muscle. For a moment, the forest feels like a stage set for monsters, each larger than life, each breathing in an atmosphere that permits such excess. But then, in the corner of your vision, you spot something else. Small, almost shy, a lizard-like form darts over a root, pausing to flick its tongue at the air. It disappears into the ferns, leaving only the faintest impression of footprints in the mud. The giant commands your attention, but the tiny one carries tomorrow in its stride. Emotionally, there is a poignancy here. The amphibians, though mighty in their time, represent a grandeur that could not last. They were tied too tightly to the water, bound to return again and again to the swamp for their eggs, their survival. The amniotes, fragile though they seemed, carried freedom inside their shells. They were the whisper of the future, the quiet counterpoint to the booming chorus of giants. In their contrast lies the tension of evolution, strength in the present versus potential for the long game. And if you lean toward humor, picture a carboniferous night camp. You huddle by a small fire, grateful for its glow, when a temnospondyle heaves its body out of the pond, belly slapping mud with each stride. Your heart races. You see jaws wide enough to snap a log. Yet just as panic peaks, a tiny reptile scurries across your boot, so small you nearly laugh. It is as though the stage has sent both its actor and its understudy at once, the giant for spectacle, the miniature for endurance. Scientists debate these dynamics endlessly, sifting through fossils of jaws, vertebrae, and footprints. Each discovery sharpens the picture slightly, but the edges remain blurred. We know the amphibians were there. We know the amniotes began their march, but the exact timing, the precise balance of power, is still a puzzle. Perhaps that is fitting. Evolution is less a clean story and more a mosaic, with some tiles missing, others cracked, and still others glowing with unexpected color. So rest for a moment in this scene. The swamp steams after rain. Amphibians lurk like shadows, their deep calls echoing through the forest. Small reptiles scuttle like whispers, unnoticed by their larger neighbors. The air, thick with oxygen, fuels them all, pressing the world into a state of constant experiment. This was the Carboniferous gift, a playground of excess, where giants and pioneers coexisted, each writing a line in Earth's unfolding script. And just as the ponds were ruled by broad-headed hunters, the skies were beginning to fill with shadows of their own. Giant wings beating against the dense, oxygen-rich air. If you're still awake with the glow of that primal fire in mind, stay with ancient Fireside. Leave a quiet like or subscribe and share your place and time so we know who's walking the night with us. The forest grows quieter as the day fades, but the silence is never absolute. Overhead, a faint hum begins, low at first, then swelling until it drowns out the rustle of ferns and the drip of swamp water. You tilt your head upward, and there, cutting across the patchy light, a shadow glides. A shape you recognize in form but not in scale. Its wings stretch wider than your arm, shimmering like panes of stained glass in the fading glow. This is Meganeura, the giant dragonfly of the Carboniferous, one of the most astonishing aerial predators ever to ride the air of Earth. The fact stands solid. Meganeura could reach wingspans of about 70 centimeters, nearly triple the size of the largest modern dragonflies. Its body was sleek and muscular, its compound eyes vast mosaics of vision, granting it exceptional ability to track movement. In a world without birds or bats, it was king of the sky, swooping over ponds and swamps in search of prey. Anything small enough to fit within its serrated mandibles, other insects, perhaps even hatchling amphibians, was fair game. In its time, this insect was not merely an enlarged curiosity. It was a top predator, flying with the confidence of undisputed mastery. Yet even predators can carry beauty. A quirky detail emerges when paleontologists reconstruct those vast compound eyes. Under certain conditions, the lenses of fossilized dragonfly eyes reflect light like tiny jewels, creating the impression of stars scattered across stone. Imagine gazing into the preserved face of Meganeura and seeing what looks like a night sky caught in miniature. In life, its eyes would have glowed in facets, reflecting the swamp light like twin constellations moving through the undergrowth. To encounter such a creature in person would have been both terrifying and strangely enchanting, as if the cosmos itself had lent its sparkle to an insect's gaze. But debates rise as soon as we try to explain its size. Was oxygen alone responsible for Meganeura's expansion, or were other forces at play? Some scientists argue that the denser atmosphere of the Carboniferous, heavier with oxygen, and possibly with higher overall pressure, made flight easier for larger wings, reducing the energy cost of staying airborne. Others suggest ecological opportunity was just as important. With no flying vertebrates to compete with, insects had free access to aerial niches, encouraging them to grow larger. There is even discussion about whether Meganeura truly reached the sizes attributed to it. Fossils can be fragmentary, and wings, delicate as they are, may have stretched differently in life than in stone. The precise measurements are debated, but the general truth remains. Dragonflies of astonishing size ruled those skies. Now pause and let yourself imagine its flight. Hear the steady thrum of wings slicing the heavy carboniferous air, each beat resonant enough to stir ferns below. The sound is deeper than the buzz of today's insects, closer to the whir of a miniature fan. As it approaches, the air around you seems to shift, disturbed by the force of its movement. The creature hovers, eyes glittering, wings catching the glint of swamp water, and then, with sudden violence, it darts, seizing an unsuspecting beetle the size of your hand. Mandibles snap, wings flick, and within seconds, the forest is silent again, save for the slow chew of a predator enjoying its meal. There is an emotional power in this scene, for it reminds us that even in alien times, some patterns repeat. Just as hawks dominate our skies today, swooping on smaller birds, and just as bats hunt insects in the dusk, so too did Meganeura patrol its kingdom. Predator and prey, hunter and hunted, these dynamics are not new inventions, but ancient scripts, rewritten by each age's actors. To watch Meganeura fly is to witness the original rehearsal for dramas that still play out in every meadow and pond today. And yet, consider the wit in imagining a world scaled this way. If you were to walk through the Carboniferous forest with modern sensibilities, you might think twice before picnicking by the water. A dragonfly larger than your dinner plate might swoop down, curious about your sandwich. The thought is both absurd and unsettling. A creature we now associate with delicate beauty turned into something closer to a hawk. In this sense, the Carboniferous plays tricks with our categories, enlarging the familiar until it becomes uncanny. Scientists analyzing Meganeura's fossils continue to probe its secrets. They measure wing veins, compare them with modern dragonflies, and run models of flight mechanics under different atmospheric conditions. These studies highlight just how unusual the Carboniferous world was, a place where ordinary rules bent under the weight of excess oxygen and altered climate. But as precise as these reconstructions may be, the fossils remain silent on questions of behavior. Did Meganeura hunt in packs or as solitary flyers? Did it patrol territories, or did it drift nomadically, following insect swarms? These uncertainties leave space for imagination, and perhaps that is fitting. Some mysteries are meant to remain half-lit, like shadows passing overhead. Let us linger for a while in this imagined twilight. The swamp smells of damp soil and moss. The air shivers with the distant crackle of fire still smoldering from an old lightning strike. Above, wings gleam briefly in the last slant of sun, then vanish into darkness. You know they are there, circling, waiting, their compound eyes catching every twitch. It is an atmosphere charged with tension, yet also strangely soothing. The knowledge that life, in all its strangeness, has always filled the air, even when no human ear was present to hear it. And in that realization lies comfort. We are latecomers to this planet's grand play, yet the stage was never empty. For hundreds of millions of years before us, wings beat against the sky, eyes glittered in the shadows, jaws snapped shut on unsuspecting prey. To listen for Meganeura is to hear the echo of a performance that continues still, though with smaller actors. So breathe slowly, deeply, and let the sound of those ancient wings carry you. Picture their long shadows slipping across ferns, their jeweled eyes gleaming in the dusk. Let the forest hold you in its damp embrace, and know that even in the strangeness of the past, there is a rhythm that feels eternal. But not all giants flew. Some crept along the forest floor, their many legs carving trails into the mud, leaving footprints as long as your hand. Footprints that still whisper from stone today. The hush of the Carboniferous forest is broken not by wings this time, but by a sound stranger still. A faint rustling, as though 1,000 leaves were shifting at once. You turn toward it, expecting perhaps the slow drip of rain or the sway of ferns. But then the ground itself seems to move, a shadow stretching across the damp earth, elongated and segmented, like a train creeping through the undergrowth. It is not a train, of course. It is alive. This is Arthropleura, the colossal millipede-like arthropod that once ruled the forest floor, a creature so large that its body alone could span the width of your bed. Here's the fact, firm and extraordinary. Fossil evidence tells us that Arthropleura could grow up to 2.5 meters long, making it the largest land invertebrate ever discovered. Its flattened, armored body was divided into dozens of segments, each sprouting a pair of jointed legs. Imagine it crawling across a swampy clearing, its legs moving in rippling waves, carrying its immense body silently but inexorably forward. Unlike the predators of the skies, Arthropleura was likely a herbivore, feeding on decaying plant matter that littered the forest floor. It thrived in the humid, oxygen-rich atmosphere, where every breath carried abundance, and where its size deterred all but the boldest hunters. But this is not simply a monster to fear. There is a quirky intimacy to the traces it left behind. Fossilized trackways, rows of parallel prints pressed into stone, have been found across what is now Europe and North America. These ancient footprints look almost like patterns carved by human hands, grooves etched carefully into mud and then frozen by time. To walk beside them today is to follow in the path of an animal that no human ever saw alive, to share a trail that once wound through dense ferns and dripping swamps. Some trackways even preserve the slight dragging of its body midsection, as if the weight of so many legs made the creature sag just a little in the middle. It is a detail so small, yet it transforms the giant from myth into something tangible, almost relatable. An immense arthropod, yes, but one that trudged with the same awkwardness as any weary traveler. And yet, despite these fossils, debate still lingers about the true diet of Arthropleura. Was it strictly a plant eater, feasting on ferns, lycopsid debris, and rotting leaves? Or might it have been an opportunistic omnivore, scavenging dead insects or even nibbling on smaller animals when hunger pressed? The shape of its mouthparts is poorly preserved, leaving scientists uncertain. Some argue its sheer size suggests a digestive system built for tough plant matter. Others insist that no creature grows to such proportions without seizing every chance for nourishment. The question remains open, a reminder that even the largest fossils often whisper more than they shout. Now, let yourself feel the presence of such a being. Imagine crouching low in the undergrowth as the segmented titan approaches. The sound is steady and strangely soothing, the patter of hundreds of tiny legs moving in harmony, like raindrops drumming on a hollow log. Its body gleams dark and damp, armored plates, catching what little light filters through the canopy. The smell of wet vegetation rises around it, mixed with the earthy musk of decay. And as it passes, the ground seems to shiver slightly under its weight, though it moves with surprising grace for something so massive. Emotionally, the encounter stirs a blend of awe and unease. Arthropleura is both alien and familiar, alien in its scale, familiar in its form. We know millipedes today, harmless creatures that curl into spirals when disturbed. To scale that form upward into a living road of legs is to confront the uncanny, to see the ordinary become extraordinary. The effect is not unlike looking at a common object through a magnifying glass until it becomes strange, the familiar turned into the monstrous by the simple trick of size. And yet, once the initial shiver passes, there is a calmness to it. This giant does not lunge or roar. It only walks, steady, deliberate, timeless. If you tilt your imagination toward humor, the thought becomes almost playful. Picture setting up camp on a log for the night, only to realize the log is moving, legs unfurling from beneath it. Or imagine a group of prehistoric children, if such had existed, riding its back like a living carnival ride, gripping its armored plates as it carried them slowly through the forest. The very absurdity of such an image makes the reality more striking. This creature truly lived, its tracks carved into stone, its body stretching beyond anything we might expect from something we think of as small. Scientists continue to argue over its role in the ecosystem. Did it have natural predators? Could early amphibians have risked attacking juveniles? Or was its size enough to grant safety? How long did it live, and how quickly did it grow? Each question circles without final answers, leaving us with tantalizing fragments rather than certainty. And perhaps that uncertainty is fitting. Arthropleura remains a mystery partly because its enormity defies our categories. It was neither wholly insect nor reptile, neither predator nor prey in the conventional sense. It was simply itself, a road of legs, a presence that defies neat labels. Now picture the forest floor again. The canopy is high above, the air thick with spores. You kneel by a damp trail and run your fingers along a groove pressed deep into the earth, preserved by chance into rock. The groove is wide enough for your hand, and the pattern of prints is so regular, it feels like an ancient drumbeat frozen in silence. You realize you are touching not just a fossil, but a moment of movement, a single walk through a swamp millions of years ago. In that instant, the giant is not gone. It is simply resting, its path continuing in your imagination. And so, as the forest darkens around you, let the rhythm of its legs lull you. Hear the steady patter. Feel the ground tremble faintly. Watch the segmented shadow pass. It is a reminder that size does not always mean terror. Sometimes it means persistence, the quiet power of simply moving forward. Yet not all arthropods were so peaceful. Some carried venom in their tails, others fangs in their mouths. And even scientists were fooled into imagining monsters that turned out to be something else entirely. The Carboniferous forest did not belong only to the wings in the sky or the legs that rippled like rivers across the ground. It also harbored hunters whose weapons curved behind them, gleaming in the half-light of the swamp. Imagine sitting by a shallow pond, the firelight of lightning still glowing faintly in the clouds above, when a shadow stirs on the muddy bank. A shape as long as your arm emerges, armored, jointed, and tipped with a stinger that glistens like a curved dagger. This is Pulmonoscorpius, the giant scorpion of the Carboniferous, a predator that carried its own venomous arsenal into battle. The fact is both unsettling and fascinating. Pulmonoscorpius kirktonensis, one of the largest known scorpions of the time, grew nearly a meter in length. Its name means lung scorpion, referencing the presence of book lungs, respiratory organs, that reveal its adaptation to breathing air. Unlike its aquatic ancestors, which skittered along seafloors, Pulmonoscorpius was fully terrestrial, stalking the leaf litter of forests and marshes. Picture its armored carapace glinting in the wet light, pincers outstretched, stinger poised high. In a world where insects grew giant, amphibians lumbered, and dragonflies ruled the sky, the scorpion claimed its place as a formidable predator on the ground. But alongside its menace comes a quirky twist. Fossilized remains of these giant scorpions sometimes capture fine details of their exoskeletons, including tiny sensory hairs that once covered their pincers. Modern scorpions use these hairs to detect vibrations, allowing them to sense prey moving even in darkness. Imagine a 1-meter-long Pulmonoscorpius crouched in silence, its hairs trembling at the faint patter of an insect's feet, alerting it to strike with uncanny precision. Now picture that same scorpion creeping through leaf litter the size of palm fronds, waiting for a beetle as long as a loaf of bread. The hairs become not just a biological quirk, but a reminder that even giants rely on the smallest of details. And then there is the story of mistaken identity, a scientific misstep that carries its own charm. For years, paleontologists believed that a fossil unearthed in Argentina represented a giant prehistoric spider, dubbed Meganeura. The specimen's broad carapace and segmented legs suggested to early eyes a monstrous arachnid, perhaps the largest spider ever known, one that could have spun webs big enough to trap birds, if birds had yet existed. The idea thrilled imaginations and fueled illustrations of nightmare creatures lurking in Carboniferous shadows. But later analysis revealed a twist. Meganeura was not a spider at all. It was a eurypterid, a kind of sea scorpion, aquatic, and long gone by the time of the forests we've been wandering. The monster spider vanished in an instant, replaced by a creature no less fascinating but far less terrifying. Science had corrected itself, but the myth lingered. Proof that even experts can be enchanted by shadows on stone. Here lies the debate, subtle yet important. What role did these giant scorpions truly play in their ecosystems? Were they apex predators of the forest floor, bold enough to challenge amphibians and young reptiles? Or were they ambush specialists, content with oversized insects and smaller vertebrates? Their size suggests power, but their physiology may have placed limits on their speed and stamina. Some researchers argue that venomous stings were more for defense than for dispatching large prey, while others insist they could have brought down animals far bigger than themselves. Without direct evidence, the answer remains suspended, like a stinger poised in midair. Now, let yourself feel the weight of such an encounter. Imagine crouching low as a Pulmonoscorpius drags itself across the mud, its legs jointed like clockwork, its pincers opening and closing with slow, deliberate menace. The smell of damp earth fills your nose. The air vibrates faintly with its movements. When it pauses, silence thickens around you, as though the forest itself holds its breath. And then, Swiftly, violently, the tail arches, the stinger flashes, and prey collapses in an instant. It is a scene that pulses with tension, yet also with inevitability. This is what predators do. They wait, they strike, they survive. There is an emotional depth to these creatures, too, once you move past the surface fear. The scorpions of the Carboniferous remind us that danger and beauty often coexist. Their armor gleamed like polished stone, their hairs quivered with delicate sensitivity, their tails curved with elegance even as they promised pain. To watch one move is to see a balance of menace and grace, a reminder that life's designs often serve both function and form. And if you lean toward humor, picture this: a scorpion longer than your arm scuttling across the forest floor, and a human, had we been there, lifting our feet instinctively, as though avoiding a house spider on the kitchen wall. The instinct to flinch at such creatures is timeless, it seems, whether the spider is the size of a coin or the size of a table. The joke, of course, is that in the Carboniferous, hiding on a chair would have done little good. The chair itself might have been half the size of the scorpion. Scientists continue to refine their understanding of these predators, re-examining fossils, scanning carapaces with new imaging technology, comparing them to modern relatives. Each discovery clarifies one detail while opening another question. What exactly did their venom contain? How far could they travel from water? How many offspring did they raise at a time? In every case, the answers remain tantalizingly out of reach, as though the scorpion itself still withholds its secrets, retreating into shadows whenever we shine a light. Now breathe slowly, deeply, and let the image settle. The forest is dark, the swamp thick with mist. A giant scorpion pauses near the water's edge, its silhouette sharp against the glimmer of fireflies. Somewhere in the distance, wings beat the air, and in the mud, long trails mark where millipede titans have passed. This, too, is the Carboniferous, a place where predators crouched in silence, where myths were born, where even mistakes in science could conjure monsters. And so, as we leave this chapter of the forest, let us carry with us both caution and wonder. For every creature that truly lived, there are others we misimagined, ghosts of interpretation lingering on stone. The lesson is simple. The past is both more and less than we think, stranger and subtler, capable of surprising us even when we believe we have seen its scariest face. But even giants must yield when the air changes. As the Carboniferous gave way to colder ages, the very breath of the world shifted, and the long feast of oxygen began to fade. If the whisper of wings and the ripple of many feet found you, you can linger here at ancient Fireside, press like, subscribe if you wish, and let us know your city and the hour you're hearing this. The Carboniferous world seemed eternal, didn't it? Forests that rose like green cathedrals, insects swollen to monstrous size, amphibians lounging like crocodiles in endless swamps. Yet nothing in Earth's history lasts forever. Atmospheres change, climates turn, and even the most generous skies draw their breath inward eventually. Toward the close of the Carboniferous and the beginning of the Permian, the age of oxygen excess began to wane. The feast that had allowed life to stretch into impossible shapes started to contract, reshaping the stage for a very different drama. Here is the fact that anchors this shift. Geological records show that atmospheric oxygen, once soaring near 35%, declined sharply toward levels closer to those of today. Multiple forces converged to bring this about. Continental drift rearranged the land, altering rainfall and drainage. Glaciation spread in the southern hemisphere, locking water into ice sheets and shifting climate patterns. Plant communities changed, with new types of vegetation altering the balance of oxygen production and decay. What had been a humid, swampy greenhouse began to give way to a drier, harsher landscape. For the giants of the Carboniferous, these changes spelled the beginning of the end. But within this sobering decline lies a quirky reminder of how history leaves fingerprints in unexpected places. Every time you strike a match to a lump of coal, every time a furnace glows with fire, you are burning not just fuel, but memories of the Carboniferous forests. The oxygen feast ended in part because so much plant matter was buried, sealed away as coal, no longer participating in the breath of the biosphere. Coal is the shadow of an ancient imbalance. Too much growth, too little decay, too much stored away underground. That imbalance first raised oxygen levels, and when the system finally caught up, the balance shifted back. The strange truth is that the very material fueling the Industrial Revolution, the black stones that drove trains and lit cities, is a record of why those ancient skies could not remain so swollen forever. And yet, as with so many stories of deep time, debate continues over the exact weight of each cause. Was the decline in oxygen mainly due to the evolution of fungi capable of digesting lignin, the tough compound in woody plants, thereby releasing carbon back into the cycle more efficiently? Or was it the spread of wildfires, which burned away organic matter and reduced the burial that had once pumped oxygen upward? Some scientists emphasize the role of shifting continents, which dried up many of the great coal swamps and reduced the areas where oxygen production had once been strongest. Others argue that a combination of these factors, each nudging the balance, brought about the decline. The truth is likely tangled, a web of causes rather than a single blade cutting the feast short. Now take a slow breath and imagine what this change felt like on the ground. The swampy air that once hummed with humidity begins to feel drier, sharper, less forgiving. Fires still rage, but the regrowth after them is thinner, slower. Amphibians, once sprawling in abundance, find their habitats shrinking, their eggs more vulnerable as ponds dry. Insects, once swollen to extravagant sizes, begin to scale back, their bodies unable to sustain the diffusion needed without such rich air. The world feels as though someone has gently turned down the volume, still alive, still vibrant, but less extreme, less overwhelming. Emotionally, there's a bittersweet rhythm in this transition. The Carboniferous had been a world of marvels, an alien Earth shimmering with impossible forms. Its decline reminds us that excess, however wondrous, rarely lasts. Abundance can fuel innovation, but stability comes from moderation. For all the strangeness we have marveled at, we now approach a landscape closer to balance, a stage preparing itself for new actors. Reptiles that would one day dominate, mammals that would creep in later, and eventually, humans who would look back and tell the tale. Yet humor still has its place, even in endings. Imagine a dragonfly the size of your arm buzzing indignantly as the air thins, finding its flights shorter, its hunts less successful. Or picture an Arthropleura, used to crawling with majestic calm, now grumbling, if millipedes could grumble, at the drier ground. its meals of rotting leaves no longer so plentiful. In a way, it is like watching a party wind down, the music fading, the guests slipping away one by one, while a few stubborn revelers linger awkwardly at the edge of the dance floor. The Carboniferous did not end with a crash, but with a long, uneven fade, a dimming of lights that once blazed too brightly. Scientists studying this decline continue to refine their models, pulling data from charcoal deposits, isotopes in rocks, and the chemical signatures of ancient soils. Each piece of evidence offers another glimpse, but the picture is always incomplete, like a faded photograph. Did oxygen levels decline in steady steps, or were there sudden plunges linked to specific events? Was the drop global, or were some regions spared longer than others? These questions remind us that the atmosphere is not just a backdrop, but a living, changing system, one that can swell and shrink in ways that shape everything breathing within it. So let yourself linger in this imagined twilight of the Carboniferous. The forests are still tall, but thinner. The air is still rich, but less intoxicating. The swamps still gleam, but their expanses are shrinking. You hear the rustle of leaves, the buzz of insects, the croak of amphibians, yet all are subdued, as though the world itself is learning to speak more softly. The age of giants is not gone, but its breath is shortening. And in that hush lies a gentle lesson. Nothing stays at its peak forever. Not forests, not atmospheres, not even civilizations. The Carboniferous reminds us that Earth is a patient editor, trimming excess, shifting balances, reshaping the script. For all its strangeness, it was one act in a play that continues still, with new players and new lines. But if we, with our human lungs, were to step back into that earlier act, into the thick of 35% oxygen, how long could we last before the air itself overwhelmed us? Close your eyes and imagine yourself stepping, body and breath, into the Carboniferous forest. At first, nothing feels wrong. The air smells lush and sweet, filled with the scent of damp ferns, rotting wood, and spore-filled breezes. But as you draw a deeper breath, something odd begins to happen. Your chest feels strangely full, as though you've inhaled more than your lungs expected. A mild dizziness creeps behind your eyes, not unpleasant at first, like the lightheadedness after running too far or laughing too long. You think, this is easy, this is effortless. But in truth, the atmosphere is playing tricks. The oxygen concentration, nearly 35% compared to our modern 21, would change everything about how we live, breathe, and even burn. The fact is unavoidable. Hyperoxia, exposure to higher than normal levels of oxygen, has profound effects on human physiology. Breathing pure oxygen at sea level for long periods can cause lung damage, seizures, or even oxygen poisoning. In a Carboniferous forest, the concentration wouldn't be pure, but it would still be enough to stress our bodies. The delicate tissues of our lungs would absorb oxygen too quickly, producing reactive molecules that damage cells. Over time, this oxidative stress could scar lungs and eyes, leading to problems far worse than dizziness. What felt like energy at first would become toxic in the long run. For us, the atmosphere of the Carboniferous would not be a gift. It would be a challenge to survive. Yet there's a quirky side to this thought experiment. Imagine striking a campfire in that forest. You drop a spark into a pile of kindling, expecting the slow build of flames. Instead, the fire leaps instantly, roaring up like a miniature inferno. your small flame, meant to warm hands or cook food, now threatens to devour the entire clearing. Even the faintest ember from your torch could ignite leaves into a cascade of flame. Cooking dinner might turn into a full-scale evacuation. And even smaller sparks, the scrape of flint, the static of cloth, could turn catastrophic. In this world, humans would have had to treat fire not as a servant, but as a mercurial god, unpredictable and dangerously quick to anger. And here lies the debate. How would humans actually fare if dropped into such an atmosphere? Some scientists argue that we might adapt surprisingly well in the short term. Athletes today sometimes train in hyperoxic environments, breathing higher concentrations of oxygen to push their performance. For brief periods, our muscles thrive on the surplus, recovering faster, working harder. But long-term living would be another matter entirely. Hyperoxia can cause oxygen toxicity in the central nervous system, leading to seizures without warning. It can also damage DNA, accelerating aging at a cellular level. Other researchers speculate that if humans had evolved in such an environment from the start, our physiology might have adapted. Thicker antioxidant defenses, different lung structures, perhaps even smaller, more efficient oxygen-absorbing organs. But as we are now, visitors to that ancient air, we would likely not last long. Pause now and picture it more vividly. You walk among towering lycopsid trees, their bark patterned in diamonds, spores drifting around you like golden dust. Your breath feels light, almost intoxicating. You climb a low ridge, hardly winded, marveling at how strong your body feels. Then, hours later, your head throbs, your vision blurs, and the forest seems to tilt around you. What began as a rush ends in confusion. The very air you trusted betrays you, filling your blood with too much of a good thing. You stumble, perhaps sit beneath a giant fern, trying to steady yourself, while dragonflies the size of hawks buzz overhead. The forest does not know or care. It is your body that cannot keep pace with its breath. There is an emotional paradox in imagining this. We humans so often long for abundance, for more air, more energy, more vitality. Yet the Carboniferous whispers a warning. Excess is not always a blessing. The giants of that age thrived because their bodies were tuned to it. But we would be intruders, overfed on oxygen we cannot process safely. The lesson is humbling. The world is not designed for us. It is we who are adapted to the world we inherited. And still, humor lingers, even in this dangerous imagining. Picture yourself trying to enjoy a simple campfire dinner, skewering something over the flame, when suddenly the entire forest canopy joins your barbecue. Or imagine children blowing out birthday candles in that age, only to set the cake and the table aflame in the attempt. Even laughter becomes a survival risk in such air. You might chuckle at the absurdity until you realize the joke is deadly serious. Scientists today sometimes model human survival in extreme atmospheres using data from diving medicine and space exploration. Divers who breathe oxygen-rich mixtures at depth sometimes experience seizures, while astronauts train for the dangers of oxygen toxicity in sealed habitats. These modern lessons shed light on the Carboniferous. Living in 35% oxygen would be like existing in a constant state of deep dive or faulty spacecraft. Survival would depend on adaptations we simply do not have. Some researchers speculate that we might have evolved differently if shaped under such skies. Smaller bodies to reduce oxygen demand, or enhanced antioxidant systems to fend off damage. But those are speculations. what ifs hanging in the air like spores, tantalizing but unprovable. Now let yourself feel the weight of this realization. You sit quietly in the imagined swamp, your lungs aching from too much air. Around you, dragonflies swoop, amphibians croak, scorpions stalk the shadows. All thrive because this is their stage, not yours. You are a guest here, one who cannot stay. You breathe in, breathe out, and know with a certainty that the forest is indifferent. The air that feeds its giants is the same air that would undo you. And perhaps that is why imagining it is so powerful. To place ourselves in that world is to confront our limits. We are not masters of Earth's history, only inheritors of a chapter that suits us. The Carboniferous reminds us that life adapts to what is given, not to what it wishes. Our lungs are perfect for 21% oxygen, no more, no less. The excess that once built dragonflies the size of hawks would reduce us to weakness. So breathe slowly now, here in your own time. Feel the balance of air in your chest, neither too rich nor too thin. Let the imagined forest fade into mist, its air receding like a dream. The lesson remains. Abundance without balance is as dangerous as scarcity, and the breath that sustains you is finely tuned to a world long changed. And as the air grows quiet, the forest itself softens into memory. The giants recede, the fires dim, and all that remains are caves, firelight, footprints, and stars, motifs to guide us gently into sleep. The Carboniferous forest fades now, like the last glow of embers sinking into ash. Its trunks, once so tall and hollow, stand in memory only, their diamond-barked columns softened into shadow. The dragonflies fold their glassy wings. The millipede titans retreat into burrows. The giant scorpions curl beneath ferns. Even the amphibians, with their broad heads resting on the surface of dark ponds, seem quieter, as though the whole forest has decided to breathe more slowly. This is the final act of a world that lived too richly, a place where oxygen swelled life to unthinkable sizes, and where, in time, that same abundance dimmed. Here lies the fact. The Carboniferous age, for all its strangeness, did not last. Its end came not in an instant, but in a long exhalation. Oxygen slipped downward, climates cooled, and the balance of power shifted. Reptiles, small and almost unnoticed at first, began to take steps into lands that giants could no longer hold. Coal seams, silent records of that time, remained buried, waiting for creatures like us to rediscover them millions of years later. When we mine, burn, or even touch coal today, we are touching the very breath of that forest, pressed into stone. And yet, there are quirky details still, small relics of wonder hidden in stone. In quarries and road cuts across the world, you can still find fossils of ferns and lepidodendron bark, preserved so sharply they resemble the carvings of artisans. Footprints, too, pressed into mud that hardened into rock, show the paths of amphibians, millipedes, and insects. Some are so clear that you can almost imagine following them like trails in the woods. These fossilized tracks are not dramatic like bones or skeletons, but they carry intimacy. They are the imprints of steps, as personal as signatures, signed not by humans, but by creatures long vanished. To lay your hand in one of those footprints is to press palm to palm with time itself. And debate continues, even now, about the meaning of it all. Was the rise and fall of oxygen an inevitable cycle written into Earth's chemistry, Or was it an accident of fungi, fire, and shifting swamps? Did gigantism vanish because the air thinned, or because ecosystems changed in ways we do not fully understand? These questions remind us that even the past is not fixed. It shifts like mist, offering glimpses, but never the whole. The Carboniferous forest remains a place of both knowledge and uncertainty, a world we half understand, half dream. Now let us slow further, soften the scene, until it drifts into quiet. Picture yourself in a cave, safe from the fires that once raged in the forest. The walls are cool stone, etched with faint reflections of light. Before you burns a small primal fire, its flames licking gently, no longer a threat, but a comfort. Sparks rise lazily into the air, vanishing like thoughts before sleep. The fire is tame here, tamed by your imagination, a far cry from the infernos that swept ancient swamps. You warm your hands, breathing steadily, the air around you balanced and kind. At the mouth of the cave, you see footprints pressed into the damp earth. They do not belong to you, though they might as well. They are the steps of creatures who lived long before, walking paths that ended in silence. Some prints are wide and heavy, like those of amphibians crawling toward water. Others are narrow and light, the tiny scurryings of early reptiles. And some, perhaps, are trails of insects or arthropods, lines of small dots crossing in patient rhythm. You follow them with your eyes until they fade into the night. Footprints, always footprints, leading away into history. And beyond the cave, when you look up, there is the starry sky. It stretches vast and calm, as it has for millions of years, yet you know it looked different in the Carboniferous. The oxygen-rich air made flames brighter, but the stars remained unchanged, scattered across the blackness like jewels. Tonight, they feel like witnesses, patient guardians who watch giants rise and vanish, who now watch you as you rest. Each star is older than the forest, older than the coal, older even than the continents shifting beneath your feet. They shine steady, reminding you that time is deeper than imagination, yet always reachable in dreams. Emotionally, this final scene is less about awe and more about release. The Carboniferous was fierce, fiery, overwhelming, yet here in this cave, with footprints before you and stars above, it becomes gentle. The primal fire soothes, the stone walls cradle, the vastness outside hums softly. It is as though the forest itself has folded into sleep, carrying its secrets into silence, leaving you to drift alongside it. And perhaps there is a quiet wit in the way it ends. The creatures of the Carboniferous never knew they were extraordinary. To them, being giant was simply being alive. The dragonfly did not marvel at its wings. The millipede did not measure its length. They lived because the air allowed them to, just as we live because our air allows us. The humor is in how we, millions of years later, sit in caves of thought marveling at them, while they simply were. So now let go of the forest. Let its sounds fade. The hiss of wings, the patter of legs, the whisper of fire. Let its images soften. The diamond trunks, the gleaming eyes, the shadows of giants. What remains is rhythm. The rhythm of breath, the steady warmth of the fire, the hush of footprints leading away, the eternal calm of the starry sky. This is where the story closes, not with an end, but with a soft settling. The Carboniferous forest breathes in dreams, its echoes lingering in coal, in stone, in stars. You are part of that echo now, breathing gently, eyes heavy, drifting on the rhythm of time itself. Thank you for resting with Ancient Fireside tonight. If you'd like more journeys like this, a gentle like or subscribe is enough. And tell us where and when we kept you company. Good night, traveler. Good night to the cave and its fire, to the footprints pressed in earth, to the starry sky above. Good night to the giants of the forest, to the insects and amphibians and scorpions. Good night to the Carboniferous world, vast and strange and gone, yet still whispering through the air we breathe. And good night to you, listening here, letting the story fold you into sleep. May your dreams walk gently through ancient forests. May your breath be steady, and may the stars guide you into rest.